Hi YouTube, this is Brendan with Cusack Prep, and in this video we're going to be discussing systems of equations problems and how to solve them through a linear combination, also sometimes called elimination. Now, in the last video we discussed substitution. The main difference with substitution and linear combination is that in a linear combination, all you're going to do is add the equations together or subtract them so that something cancels out. Now, in this case, we have negative y and we have y. So if we just add these straight down, x plus 2x is going to give us 3x. Negative y plus y, well, that just cancels out. That's 0. And then 3 plus 12 is going to give us 15. Now, if 3x equals 15, we can divide both sides by 3. And when we do that, we find x is equal to 5. Once we know x is equal to 5, we can plug it back into either equation and use it to solve for y. So if I plug 5 into the first equation, I get 5 minus y is equal to 3. Subtracting 5 from both sides, I come up with negative y is equal to negative 2. Dividing both sides by negative 1, I find y is equal to 2. So that means that the point 5, 2 is my solution to the systems of equations. What does that mean? That means that if I were to graph these two equations, the point 5, 2 is where they would intersect. Now taking a look at the next one, we see something's a little bit different. Here we had negative y and y, and they just canceled out perfectly. Well, here we don't have that. We have 3x and 6x, which don't cancel out. And we have 5y and 2y. Well, those don't really cancel out either. So what can I do? One thing I can do is I can multiply the whole top equation by 2. If I multiply it by 2, this is going to become 6x plus 10y is equal to 4. I go ahead and cross that off. Now, here I can't add these, right? Because 6x plus 6x, that's not 0. So what I do is I subtract them. And when I subtract them, I like to put parentheses around the side. 6x minus 6x, well, that's 0x. 2y minus 10y, well, that's going to go ahead and that's going to give us negative 8y. And 7 minus 4, well, that's going to give us 3. Dividing both sides by negative 8, we would find y is equal to negative 3 over 8. Now we can take this value and we can plug it back into either, any one of those three equations. Generally people choose to plug it back into one of the original ones. I'm going to plug it into the first one. So 3 times x plus 5 times negative 3 over 8 is equal to 2. Now 3 times x is 3x. 5 times negative 3 is going to be negative 15 over 8. And that's equal to 2. Well, don't let the fractions confuse you. We just solve this the way that we would solve any other linear equation. We're going to add 15 over 8 to both sides. And we have to remember that if we're adding 2 to 15 over 8, 2 is like 2 over 1. To get the least common denominator, we would have to multiply this by 8 over 8, which would give us 16 over 8 plus 15 over 8. Adding straight across the top, we get 31. Keeping the denominator the same, well, that's just going to be 8. What we have to do next is divide both sides by 3. However, since there's fractions, I prefer to think of multiplying both sides by 1/3. Because here, these 3's will cancel out. We'll just be left with x. And 31 times 1, multiplying fractions, you multiply straight across the top, and you multiply straight across the bottom. There's no need to find the least common denominator when you're multiplying fractions. You just multiply right across the top and right across the bottom. And x equals 31 over 24. Now, if we take our two answers together, we would have the point 31 over 24, comma, negative 3/8. Again, an ugly point, but that just reflects the numbers that I picked for the equation, and there's nothing wrong with that. You can intersect at a fraction on a graph. Thank you for watching. Hope you found this video helpful.